Alright guys, welcome to our channel once again. Today you'll learn about the concept of hybridization in carbon. So hybridization is essentially the mixing of standard atomic orbitals to form new orbitals. So we know that carbon in the ground state has the following electronic configuration. That's 1s2, 2s2 and 2p2. So with this, if I take the 2s orbital this way and the 2p orbital this way, I'll notice that I have just two unpaired electrons. So I have two unpaired electrons. So this means that I can only have two bonds in the ground state. But then we know that carbon always forms four bonds. So this is where the concept of excitation comes into play. Now, for this carbon to form up to four bonds here, the electrons have to be excited. So when I take this, an electron from here and fix it over here, now that is just the major concept of excitation. Now this means excitation. This, in the excited state, an electron will leave the s orbital and then migrate to fill the empty p orbital. So ultimately we'll have this. Where I have the 2s orbital and I have the 2p orbital. So notice that the remaining one electron here migrated from here to fill up this empty p orbital. So this is a process of excitation. Alright, so having gotten the concept of excitation, I'd like us to now proceed to the hybridization of orbitals. So let us take note that alkanes are sp3 hybridized. Alkenes, on the other hand, are sp2 hybridized, while alkynes are sp hybridized. Alright, so having gotten these concepts, let's look at the hybridization of alkanes. So basically, if we have this, so let's recall that the hybridization is simply the mixing of the orbitals. So this is 2s and this is 2p. So for alkanes, the mixing will occur in this manner. The 2s will mix with the 2p just this way, and then they'll form an sp3. So notice that the 2s here is mixing with the whole 3 electrons in the 2p. So we have s and then we have 3 in p. So we have 1 in s, we have 3 in p, so making it sp3. So we have an sp3 hybridization in alkanes. Alright, so for alkenes we have our s orbital here, and we have our p orbital here. So mixing occurs in such a way that the s here mixes with 2 of the p. So we have 1p left aside. So this gives us sp2, because these two will mix with this s, so we have sp2. So the whole of this is a sigma bond, and then we have the remaining 2p. So this is 2pz, and this gives a pi bond. So with this we can tell that alkanes exhibit an sp2 hybridization. So let's go ahead and wipe this. Now for alkynes, when we have this is our s orbital, specifically the 2s orbital, and this is our 2p. So if mixing occurs, or if there is a hybridization, perhaps one of these will mix with this, and then ultimately we'll have just one from here and one from here, and as such we can say this is sp hybridized. Alright, so if only these should combine with this, then 2 of these will be left. So we have the 2py and 2pz left. So this gives pi bonds for this, and then sigma bonds for this. So with this we can tell that alkynes are sp hybridized. So in summary, I'll simply make a table to show the hybridization states of carbon. So over here I'll have an example. So over here I'll have number of bonds. So down here I'll have the hybridization. And then lastly I'll have the shape. So notice that an example of the alkane is the CH4, and the structure looks quite like this. So it will have 4 bonds. So remember it's sp3, so the hybridization is sp3 for the alkanes. And then looking at this is tetrahedral in shape. So next I'll have an alkene here. So let's call this the number of sigma bonds. We have 3 sigma bonds. So this is the first sigma bond, this is the second sigma bond, this is the third sigma bond. This over here is a pi bond. So this is sigma, this is sigma, this is sigma. So if it's a double bond, now this over here will be a pi. So I have just 3 sigma bonds. So this is sp2 hybridized, and the shape is trigonal planar. Alright. Lastly, I have either of these or these. So notice that I have a sigma bond here, I have a sigma bond here, that's 2, whereas this is pi and this is also pi. So this is a sigma bond, this is a sigma bond. The additional bond here is pi. So you notice this will yield just 2 sigma bonds, this will also yield just 2 sigma bonds. So I have 2 sigma bonds here, and this is sp hybridized. And what's the shape? The shape is linear. So that's all about the hybridization in carbon, guys. So if you enjoyed the video, please give it a thumbs up. Also ensure to share with your friends and subscribe to our channel. Thank you.